In this video, we're going to learn how to calculate the average value of the functions. So let's start with the idea of calculating the average value of the finite number of the numbers. So we're given only five numbers, and in order to calculate the average of them, we just need to sum all of these five numbers and divide this to the 5. It gives us the average of these five numbers. So now what happens if I'm given the infinitely many numbers and I would like to find its average? For example, let's say we're given a function of the temperature during the day and you have infinitely many records of the temperature during that day. Or for example, you're going to go to another city and during your trip you're going to record the velocity for each instance of the time, and then you're going to know what was the average velocity during the trip. So basically we're going to have infinitely many records of the temperature or the velocity, and then we would like to calculate the average temperature or the average velocity. So the idea is like this. So I would like to split the interval from a to the b into the n subintervals or into the n parts. Then by calculating the average of the value of the function in those endpoints, we can find the average of the function roughly inside this endpoints, approximately, right? So let us divide the interval into the n equal subintervals. So it means that the length of each of the subinterval is going to be the length of the interval divided to the n. So basically b minus a divided to the n. Then we choose the sample points from each of the subintervals successively. So basically x0 will be equal to the beginning of the interval. Then every next sample point I'm going to derive by adding the delta x to the previous ones. And then I'm going to find the values of the functions at those sample points. And in order to find the average of those values of the function, I just would like to add all of them and divide them by the n. So it gives me the average value of the function approximately. So why approximately? Because I'm taking only finite number of the points for my function inside the interval. And obviously, if I would like to get more precise result, I just need to increase the number of the sample points, right? So in order to do this, let me write the n as the b minus a divided to the delta x here in this function. Then if the delta x goes to the numerator, my average function will have this kind of formula, so which can be written in the compact form in this form, right? So now if I just increase the n, my result should be more precise. So the limit of this formula is going to be equal to the integration of this function in the interval from a to the b divided to the b minus a, and this summation is equal to the integration according to the definition of the definite integral. So let's do now an example, then we're going to consider the illustration of this example in the programming language. So let's find the average of the function f of x 1 plus x squared in the interval from -1 to the 2. According to the formula, we just need to integrate this and divide this as the length of the interval. So the integration of this function is equal to the x plus x cubed over 3. So we need to put the values of the t and -1 and multiply this to the 1 over 3 because the 3 is the length of this interval. So it's going to be, so if I put the 2, it will be 2 plus 8 over 3. And if I put the -1, it will be -1 over 3. If I just subtract them, I'm going to get 1 over 3 multiplied to the 6, which is equal to the 2. So now let's do the simulation. So this is R, the programming language which is used mostly to work with the data. And I'm going to calculate the average of the function of our function 1 plus x squared inside this interval by just dividing this interval into the different number of the points. Okay, so let's say we're given sum is equal to the 0 in the beginning, and delta n is equal to the 10, and the delta x is equal to b minus a, which is the length, right? 3 over n. And now I just need to write a for loop where x goes in a sequence of from -1 until 2, and we need to add the numbers sequentially by the delta x, right? So the sum will be sum plus the value of the function at those points, right? At the points x. So basically, I'm just going to show you what happens with the sequence. So for example, if you just write a sequence here with the 0.1, it's going to give you an array of the numbers from -1 until the t by just adding the 0.1. Okay, so you see, so it gets the -1 and it adds the 0.1 until you'll get a t. Okay, so what we're going to do is we would like to assign all of those numbers in a sequence to the x, and I'm going to calculate the value of the function, right? The function was 1 plus x in the square, and I would like to sum all of the values of the function in the sample points, and in the end I just need to divide the sum to the end. It should give me the average function, average of the function. So let us run this code. So I've got a t-point 365, which is far away from the t, right? So we just calculated using the integration that the average of the function is equal to the t. So now let me just increase the n by 10, so it's going to be 100, and let me run the code. So now it is much better, right? Much closer to the t. Now if I just increase the n, if I just take n a huge number, it's going to be really close to the t. So our idea is like a divide the interval into the as really infinitely many subintervals and calculate the values of the functions there and take